Okay, after the motor start to move, so then the motor will rotate up to the certain voltage, so at certain speed. Okay, so then these topics will cover how or what is the method so that we can control the speed of induction motor. Okay, so there are two techniques to control the speed of induction motor. So the first one is to vary the N-sync. So as we know that N-sync is equal to 120 Fe over number of pole. So by changing the Fe, okay, for example, we want to increase the speed, so we can increase the frequency, or we can reduce the number of pole. Okay. Besides, the second one is vary the slip. Okay, so by changing the voltage and also the rotor resistance. So we look first at by changing the pole. Okay, so by changing the pole, either increase or decrease, because this is indirectly proportional. So 1 over inversely proportional, okay, to the number of pole. So by increasing number of poles, so we'll reduce the number of N-sync. However, this technique is a very old technique and greatly obsolete today. Okay, because you need to change the wiring and so on of the motor. Okay, then changing the line frequency. So as we know that from the Faraday's law, so we know that the induced voltage is equal to N d flux over dt. So now we to find the flux, okay. So to find the flux, at this point we assume that E induced, okay, E induced equal to Vm sin omega t. Okay, so over here is 1 over N Vm sin omega t. So then we will get this value, this equation. Okay, so by solving the equation, so we get the complete equation over here. Okay, so if you can see from here that the flux is equal to voltage, maximum voltage divided by the omega np, number of turn. Okay, from here we can see that the flux is indirectly proportional or inversely proportional. So omega is 2 pi f, okay, the frequency. Okay, so by changing the flux, the frequency, okay, so by increasing the frequency, the flux will reduce. Okay, however, if we reduce the flux at the frequency, the flux will increase. Okay, so by reducing the flux, so reducing the frequency, okay, then the flux will increase. And we know before that there is a BH parameter, or the flux, okay, and also the current, okay, the current graph, the current curve. Okay, so that there is a saturation. Okay, so by increasing the flux, automatically will increase the current. Okay, so excessive magnetizing current flow into the motor, so they will cause the motor to be overheat, and also can make a spark, and also can burn. Okay, so then what we can do is, so to decrease the magnetizing current, voltage applied to the stator need to be decreased. Okay, so we need to also decrease the voltage. Okay, thus the maximum power rating of the motor must be decreased to avoid the motor overheat. Okay, so this is the equation of the power. So by reducing the voltage reduced, the power also will be reduced. Okay, so now what happened when we change the voltage, okay, the line voltage. Okay, so from the equation we found that from the equation we know that the torque, okay, actually is proportional to the applied voltage. Okay, so if you can write again, so the T induced is equal to, so 3 VTH, okay, T VTH square R S over S, okay, divided by omega sin RTH plus R2 S square plus XTH plus X2. Okay, so the RTH actually from here is including everything. So therefore they say the V apply. Okay, so the V apply also include in the V Thevenin. So once the voltage is reduced, okay, by changing the voltage, so we reduce the voltage, the torque also will reduce. Okay, voltage reduce, torque also will be reduced. Okay, the changing of torque will vary the motor speed, and it can be analyzed from the torque speed curve. Okay, so sometimes use a small motor or fan. So this is the torque. Okay, if for example, this is the dashed line over here is the load. Okay, the load parameter. Okay, so the load here is not linear. Okay, so they say sometimes used for a small motor or driving fans. So this is the load curve. Okay, so if you use the voltage, the initial one, so it is too high. Okay, so we can reduce. Okay, we can reduce, so that over here you can see that this is at the N, at N1, I can say N1. So of course when we reduce the voltage, okay, we reduce the voltage, the torque will also reduce, and it will cause the Nm to also reduce. Okay, so if we reduce more and more, we get the new speed. So we can say the N1 is greater than N2, and N2 is greater than N3. Okay, as long as the load can be moved to a certain speed that we want, so that the speed will be reduced. Okay, this is how we control the speed. However, we need to look at the load parameter, the load characteristic. Okay, sometimes the load is not linear. Okay, sometimes the load is non-linear like this. Okay, then we move to the control the motor by changing the rotor resistance. Okay, so I believe I touched this before. Okay, because you can see from the S, okay, the slip, okay, the slip is directly proportional to the R2. Okay, so it is applicable for one rotor induction motor only by inserting extra resistance. Okay, so at this point the slip, okay, the slip is proportional to R2, while the torque is independent. Okay, independent of R2. Okay, so whatever value we change to the R2, the torque is still constant. Okay, the torque is still the same, remain the same. Okay, so by changing the R, okay, they will change the value of the value of speed. Okay, for example, this one is the torque max. Okay, this is when at the torque max. For example, the Nm. Okay, the Nm is equal to 1,500. Okay, RPM. Okay. So then when we increase the value of R, okay, for example over here is R1 is equivalent to R2. Okay, so we'll increase the R. Okay, we'll increase the number of slip. Okay, so please be remember that the slip is over here is equal to 0 and this is equal to 1, because this is Nm equal to 0 and this one Nm equal to Nsync. Okay, so therefore they get as slip is equal to 0. Okay, so when we increase the value of R, the slip will increase. Okay, the slip will increase, so this is the new M, the new slip. Okay, so this is X max prime. Okay, so one more time we increase the number of R, so there will become a new slip, double prime. Okay, so same goes to others. So it's not possible. It is possible actually. It is possible when we change the number of the value of resistance. The starting torque. Okay, you can see here the starting torque is equivalent to the maximum torque. Okay, so for the R5 over here. Okay, then this is how we control the motor.